In this video, we're going to take a look at properties of radicals. They're almost the same as the properties that we've seen before. In fact, they come from the properties from before. If we have something inside a radical with an index of n, that's the same thing. We can split that up. And I'll show you why. We can split that up between a and then times the nth root of b. That's just the same thing as saying, well, I have a times b raised to the 1 over n, right? Well, I can use the property of exponents that says I can distribute that. So that's the same thing as a to the 1 over n times b to the 1 over n, which is the same thing as that. So, yeah, we don't even, technically we don't need this, but it's good to recognize that it works the same with square roots. That's because some people don't recognize that. Just like the other rules, we can also go in either direction. So if we had two radicals that are separate but they have the same index, then we can write them underneath one radical, or we can split up, whichever one is more convenient, and it helps us simplify the problem. Another rule, well, this one's multiplication. Of course, you think it's addition. No, division is next. So if I have the division of two different bases, and they're underneath a radical, I can split up the radical again. So there you go. And of course, I can also go backwards. So there are those two, and let's take a look at an example for those. So for these ones, I'm just going to be using each of those rules. I have my calculator out right now, and I'm thinking, oh, I can just do 12 to the 1/3, and that's true. I could just do that, but I get some weird decimal, and it turns out same thing happens for that, except for I get a different decimal. But what I could do, since these are the same index, just like here, they're the same index, I can go backwards. So that's what I'm going to do. I will write it underneath one radical, and I'll have 12 times 18. I don't know what that is, but I have a calculator. I'm going to do that in my calculator right now. 12 times 18 is 216. And then, okay, yeah, now in my calculator I can do 216, and I'll try this to the 1/3 and see what that is. And that turns out to be just regular old 6. So even though it wasn't nice here and it wasn't nice here, if we put it together, it comes out to be nice. If you wanted to do this and raise 12 to the 1/3 and write down that decimal, and then do this part and have 18 to the 1/3 and write down all those decimals, or write down that decimal number, and you multiplied this and those two decimals together, you would actually get 6 as well, except for doing it this way just allows you to not have to write down those decimals. It simplifies things. We'll be doing it without numbers. We'll be doing it with variables as well, but for right now, it's showing you that the properties work with the numbers. Same idea here. I'm going to use this rule to go backwards, and that would be 80 divided by 5, all underneath the same radical. Well, 80 divided by 5, that's 16. And I have the 4th root there, which means I could do that, and then that in the calculator is just 2. So even though if I did that here and here, I would get 2 decimals, and then I divide them, I could get 2. I can simplify without doing that, and then maybe guess and check. So I could do it all without a calculator. But there you go. I'm going to stop this video and do some more examples in the next videos.